Okay, class. We are continuing on for the battle for story problems. And today we're going to kind of put it all together. So if you want to go ahead and label your paper 1-7, a problem-solving plan. Now, we're going to find out in our book, especially when we start doing story problems, starting today, forever and ever, amen, we're going to use the 5-step plan. Okay? The 5-step plan. And if you look on page 27 in your book, all the 5 steps are actually written out. Now, if you look there, the first 3 are going to look very familiar. Okay, very familiar. If you're on page 27 in your book, step number 1, read the problem, decide what unknown numbers are asked for and what facts are known. So it's just like what we did last night for homework. Step number 1, what are we solving for? What are we trying to find? Step number 2. Choose a variable and use it with the given facts to represent the unknowns. So just like last night, step number 2 is going to be our let statements. Step number 3, reread the problem and write an equation that represents relationships among the numbers. Okay, so just like last night, step number 3 is writing the equation. We've got to be a good detective, find those clue words, find where the equal sign goes, and be able to translate those words into a math sentence. Now, the new part for us today is step 4 and step 5. So if you look at step 4, it says solve the equation. So finally, we're going to solve the equation. Now, it's very important in step 4 that you remember to answer the question. And then step number 5, the step that everybody forgets to do, is the step that requires us to check your results. Okay, check your answers, make sure they're correct. So this is one of those times it's easier to show you than to tell you. So let's go ahead and turn over to page 28, and let's look at number 2 in the problem section. We're going to do, my goal is to get 3 story problems, 3, maybe 4 story problems done today as we go through and look at this new plan, the 5-step plan to solve story problems. So everybody look at number 2. Number 2 says, the gym is 21 years newer than the auditorium. The gym is also 1/4 as old as the auditorium. How old is each building? And then they added something this time. It says choices for the auditorium's age are 26, 27, and 28. Now, what did they just give us? When they tell me the choices for the auditorium age is, nice, yes, they just told me the domain. So just like when we were in section 1-3, when they give us the domain, we have to do an input-output chart. All right, but the other cool thing about them giving me the domain is they also really just told me my first let statement. All right, so let's go through here and let's see if we can take care of this problem. So remember, step number 1, what are we solving for? So if you go back through and read it to yourself, usually what they're asking me to solve is the last sentence. How old is each building? So step number 1, we want to find the age of each building. Okay, now, step number 2. Remember, step number 2 are the let statements, and they gave us a hint. Our first let statement has to do with the domain. Now, I'm going to go ahead and pull out the work here. Okay, so here's step number 2. Step number 2, well, they told me that the choices for the age of the auditorium is 26, 27, and 28. So that's my first let statement. Let A be the age of the auditorium. What's my let statement? Next let statement. We need a let statement for the gym. The gym is 21 years newer than the auditorium. Ooh, newer. What operation do you think goes with that? Yeah, nice. Okay, we've got A minus 21. Okay, because it's newer, we're going to subtract the age from the age of the auditorium, and that's going to give me the age of the gym. Now, did you notice something else there? The gym is also. So the gym is also a quarter of the age of the auditorium. All right, so those are my let statements. Now, that is also is very important, okay? That is also is my equal sign. Remember we talked about that yesterday, as long as it is or some kind of state of being verb. And so we know that the age of the gym can equal is also the age of the gym. So everybody look at step number 3. Look at my equation. Does that make sense to everyone? Yeah, it does, okay? Because it says is also the first age of the gym, okay, is going to equal the second equation that has to do with the age of the gym. Is also was your key words there. Okay, so now that we've got steps 1, 2, and 3, just like we did last night for homework, now we've got to take our domain. They told us the age of the auditorium, and here it is. Here's our input-output chart. Remember, when we set up our input-output chart, my first column is the domain. The middle column that I put in there is the math. Okay, I usually put my equation there so it's easier for me to see when I'm substituting in. And then the last column is where we decide whether we have a true statement or a false statement. So let's look at the first number in our domain, 26. We've got 26 minus 21. Well, that's 25. 25 does not equal 1/4 of 26. Okay, let's try our second member of the domain. Well, 27 minus 21 is 26. Is 6, I'm sorry. 6 does not equal 1/4 of 27. That'd give me a fraction, 27 over 4. Let's try the third member of our domain. Yes, 28 minus 21 is 7. And when I look at that, 1/4 of 28 is 7. So 28 is our true statement. So remember, when we get our true statement, that's our solution. So 28 is the answer. Now, after you've done all that work, you've done your input-output chart, and you've found your true statement, you've got to make sure to answer the question. So what was the question? Well, to answer the question, we got to go back up here to step number 1. We're trying to find the age of the building. So when we got that true statement on 28, remember that was A, which was the auditorium, so we can say that the age of the auditorium is 28 years old. Well, that's the auditorium. What's the age of the gym? Well, we're going to have to go back over here to our let statements, and basically, let me get rid of some of the work here, okay? Basically, you can put it into either equation, and I would do the subtraction one. Seems to be a little bit easier. So 28 minus 21 is 7. And so that is my answer. So make sure you've answered the question. Okay, now we need a check. The easiest way to check is to go back and plug your answer in to your step 3 equation and prove that it's true. So we say A is 28, so 28 minus 21 equals 1/4 of 28. So we're going to get 7 equals 7. And make sure you put a check by your check. So I realize that's what it is. So did you realize technically your true statement in your input-output chart is your check? So you can just copy it over. All right, very nicely done. Now let's try another one. Let's try another one. Let's go over here and let's look at number 12 on the next page. So if we flip over and look at number 12 on page 29, here's what it says. Leah and Barb started at school and jogged in opposite directions. After 30 minutes, they were 10.5 kilometers apart. Barb had traveled 1.5 kilometers farther than Leah. How far did each jog? Choices for Leah's distances are 4.5, 4.6, and 4.7. Okay, so we've got to use our 5-step plan. So when I look here, okay, what's step number 1? Okay, step number 1, what are they solving? What are they asking us to solve for? Remember, now that's usually the last sentence. So step number 1, we're trying to find the distances of each girl. Okay, the distances of each. All right, so step number 2 is our let statements. After 30 minutes, they were 10.5 kilometers apart. Barb had traveled 1.5 kilometers further than Leah. Remember yesterday, Mrs. Burton said the last shall be first? Who's mentioned last? Leah's mentioned last. So that means the let statement for Leah, and Mrs. Burton did a little drawing here by the help of some clip art. But that means since Leah was mentioned last, her let statement is x equals distance Leah jogged. If we go back there and read, what did it say about Barb? Well, Barb was 1.5 kilometers more than Leah. Well, more than implies plus. And so there's my second let statement. Now, step number 3, we've got to come up with our equation. Okay, after 30 minutes, how far apart were they? Yes, 10.5. So here's my equation. We needed that other number, okay, so we could put it all together and get our equation. Now remember, step number 4, we're going to do our input-output chart. If you notice, these were the choices for the domain that were given in the problem. We get a true when we do 4.5. So now that the chart's done, don't forget to answer the question. And the question was the distances of each. So when we got true for 4.5, that meant Leah jogged 4.5 kilometers. How about Barb? Well, if we look at Barb's let statement, it's 4.5 plus 1.5, which is 6 kilometers. So there's my second answer. Two people jogging, 2 answers. Now, the easiest way to show me the check, step number 5, look what I do. I go over here, and if we add those 2 together, what do we get? 10.5. Make sure you put a check there. Nicely done. Okay? Nicely done. Now, here's what we're going to do. We're going to try 2 more off of your worksheet. Let's see if I can get there. All right? So let's go ahead and look at your worksheet, and everybody flip it over, and let's look at number 1 on your worksheet. Okay? Let's look at number 1 on the worksheet. So when I flip it over, okay, number 1 says, in the chorus there are 12 more boys than girls. There are 32 students in the chorus. How many boys and how many girls? Choices for the number of boys, 8, 10, and 12. So step number 1. Step number 1, what are we trying to find? Yeah, we need to find the number of boys and girls in the chorus. Okay, that's what we need to find. Step number 2. You got to define the variables. We need our let statements. They gave us a hint. Who was the domain for? Yeah, choices for the number of boys are 8, 10, and 12. Guess what? For boys, I'm going to let B equal boys. Okay, what's going to be the let statement for the girls? What did it say? There are 12 more girls than boys. Okay, 12 more girls than boys. So B plus 12, 12 more equals girls. So there's my 2 let statements. Step number 3. There's another important piece of information there we need. What's it say? There are 32 students in the chorus. All right, so here's my equation. The boys plus the girls. Both of my let statements go in my equation. How many students are in the chorus? 32. So does everybody understand steps 1, steps 2, and step 3? Exactly like we did last night for homework. Now, step number 4, what do we need to do? Yes, that input-output chart. So here we go. Okay, B is our domain. What was it, 8, 10, and 12, I think? Yes, 8, 10, and 12. Again, I like to put the equation in the middle so I can make sure I don't make any mistakes when I'm doing my substitution. And then we've got to decide true or false. So let's go. If I go with the first member of the domain, we've got 8 plus, and 8 plus 12 is 20. Well, that does not equal 32, so that is false. Everybody understand what we did? All right, let's try the next member of our domain. It was 10, so 10 plus, parentheses is 10 plus 12 is 22. Aha! Guess what? 32 does equal 32. That's our true statement. And then still got to do the math for the last one. 12 plus 12 in the parenthesis is 24, and that does not equal 32, so that is false. So remember, we got a true statement on 10. All right, so we found the true statement, we found the solution, but does that answer the question? Well, it does answer part of the question. Okay, the question, if you go back up to step number 1, we've got to find out the number of boys and girls. So when we found B, B was the number of boys, so we can go ahead and say that is 10. How about the number of girls? Well, if we look at our let statement here for girls, we need B plus 12, so that's going to give me 22. And then don't forget step number 5. Step number 5 is the check. Guess what I would do? I would go over here, I would add those together, and I would put my check. Nicely done. Very nice. Okay, last one we're going to look at. Last one we're going to look at is number 7. Everybody look at number 7. Okay, we're on the back of your worksheet. Number 7. It says, one number is twice another number. The larger number is also 32 more than the smaller number. Find the numbers. Choices for the smaller number are 32, 40, and 48. Okay, 5-step plan all the time. Step number 1. Okay, we're trying to find numbers, plural. Find numbers. Okay, step number 2. I need some let statements. What was our hint? What did they say for the domain? Oh, check. Choices for the smaller number are 32, 40, and 48. So, guess what? I'm going to let n equal the smaller number. And again, you get to choose the letter because you are the author. Okay, now, what's the larger number? Let's go back and read the first sentence. Well, remember, the first sentence usually gives us our let statements. One number is twice another number. How are you going to show me twice a number? Yeah, that means times 2. So 2n is going to equal my larger number. Okay, so those are my let statements. Now, we've got to come up with the equation. Let's read that second sentence. Remember, I said the second sentence usually helps us figure out the equation. It says the larger number is also 32 more than the smaller. The larger number is, there's is means equal. Well, which one of the let statements goes with larger number? Yeah, it's this one. So the larger number is, so I said is, should be a equal sign, sorry about that, is 32 more than the smaller. What was our smaller let statement? And then we need 32 more. Now think about that. Does that make sense? Can you be a good detective and really look at that second sentence and be able to break it up? The larger number is means equal. There's my box. What's the let statement that goes with the larger number? 2n. The larger number is 32 more than the smaller. Great job. All right, you know where we go now. We got to do our input-output chart. So we've got 2n equals n plus 32, and n, and I forgot our choices. Okay, 32, 40, and 48. 32, 40, and 48. Okay, here we go. I'm going to go with blue this time. So we've got 2 times 32 equals 32 plus 32. Well, that's true. Okay, so here's our true statement. Remember, we still got to fill in the input-output chart. So we've got 2 times 40, which is 80, does not equal 40 plus 32, because that's what, 72. Let's plug in the 48, and we're going to find out that doesn't work either. So those are both false. Who gave me a true solution? Okay, who gave me a true statement? It was 32. So remember, that's my solution. But now answer the question. What's the question? What does step 1 say we need to find? We need to find the numbers. So the smaller number, which is n, which is what the true statement was on my input-output chart, is 32. What's the larger number? Yeah, remember, look at your let statement. The larger number was 2n, so 2 times 32 is 64. Okay, now step number 5, we need a check, and I would just plug them in to my original equation there. Equals 32 plus 32, so 64 does equal 64. Okay, so students, you have 9 different story problems tonight, and for each story problem, you need to give me the 5-step plan. Okay, you may begin your homework.